The story starts in 2021 when Dr. David Giblin at the University of Washington Herbarium started the Washington 50 Peaks Project with the goal of conducting botanical surveys on 50 alpine summits in the Cascade Mountains of Washington over a 5-year period. Dr. Giblin started the program because the alpine flora and its distribution is relatively poorly documented in the state. He also saw the project as an opportunity, as an educational opportunity to get some of his students some field botany experience. Well, botanists and ecologists from other states kind of got wind of this 50 Peaks project in Washington. They liked the concept and thought collecting similar information in their states would be beneficial. So in 2022, botanical surveys in alpine environments were conducted in New Mexico, Colorado, Wyoming, British Columbia, and Idaho. So it started really as just a Washington project, has quickly developed into a floristic botanical survey of alpine environments in the Western United States, Western North America, actually. So it's become a collaborative, multi-jurisdictional project. And the Idaho Peaks Project is Idaho's contribution to this collaborative effort. We started in 2022 with the initial goal of conducting surveys on 25 peaks in over a 3-year period. The Idaho Peaks Project is an all-volunteer project with the support from the Idaho Native Plant Society.
That's the part that I want to make sure is going to work.
Okay. Okay.
Yes, no.
All right. Well, Idaho's alpine has received less botanical scrutiny and documentation compared to like forest, sagebrush steppe, riparian, and other lower elevation, easier to access ecosystems in the state. And this was highlighted when I did a query of the Consortium of Pacific Northwest Herbaria database. This database contains the majority of all herbarium records collected in Idaho for the past 100+ years and deposited in regional herbaria. What I found was that only about 2% of all Idaho collections were made at elevations of 10,000 feet or higher, which is about the average elevation where alpine starts in Idaho. So with this in mind, we have 3 main floristic goals for the Idaho Peaks Project. On the screen here, to obtain a more comprehensive accounting of Idaho's high alpine plant diversity, to better understand the distribution of this diversity, and also to document high elevation populations of species on Idaho's rare plant list. There's also a 4th goal, and that's more of an educational component, and that is to, again, similar to the Washington, is to provide high elevation field botany experience to INPS members, students, and anyone else interested in alpine ecology and botany. I just want to quickly review some concepts about the alpine. And first, to be clear, when I say alpine, I'm talking about all the vegetation that occurs above the natural upper tree line in the high mountains. And this transition ecotone between forest and alpine often can be quite abrupt, as you can see in the top photo. But in many cases, it's more gradual, where you have a few trees marching up the slope, or more of a mosaic pattern, as these bottom photos show. Low temperature is the overriding factor that controls the boundary between the alpine and upper tree line. And basically, to get tree growth, you need a certain minimum number of days at a certain minimum temperature, mean temperature. Worldwide, alpine vegetation is estimated to cover about a little less than 3% of the Earth's land surface. About 75% of this is in Asia, about 15% in South America, a little less than 10% in North America, about 2% in Europe, and less than 1% in Africa and Oceania. Alpine floristics. The alpine flora of the world is estimated at about 10,000 species and about 100 plant families. This represents a little less than 3% of all flowering plant in the world, and a little less than maybe a quarter of all the plant families. From a species richness standpoint, the aster family and the grass family are the most important alpine families in the world worldwide. But other families such as the mustards, the rose family, the carnation, the sedge family, and the buttercups are also often pretty prominent in alpine environments around the world. In Idaho, elsewhere in the Rocky Mountains, probably everywhere actually, the alpine vegetation is not a monoculture, but instead is usually a mosaic of various plant communities with a varying composition and cover, depending on interacting factors such as the amount of soil development aspect, this underground hydrology, snow retention, and microtopography, which combine all these things combine to form a mosaic of different habitats on a summit. Some of the main plant community types we have in Idaho are fell fields, scree fields, and alpine turfs. I'll just talk about those real briefly. First is fell fields. They're characterized by dry, rocky, shallow soils and vegetation that's dominated by cushion plants or match forming plants. There's high cover of stable embedded rocks in the surface, and these can often have a high cover of lichens. Floor cover is usually greater than graminoid cover. So this picture on the bottom here, you can kind of see the high lichen cover on some of these rocks, and then the relatively sparse vegetation cover and high rock cover. Some of the common species you might find on fell fields in Idaho are alpine sandwort, mat milkvetch, landsleaf stonecrop, and various species of phlox, including cushion phlox. So they'd be quite colorful. And let's not forget alpine forget-me-not. And alpine old man of the mountain, several species of draba, one of them being few-seeded draba, and then cushion buckwheat. So these are all plants that commonly come across in fell field habitats in Idaho mountains. Alpine turf kind of comes in a dry version and a wet version. In both cases, the soil is relatively stable. In the moist version, the main difference is that it has a reliable, consistent source of water throughout the growing season. And also that the vegetation is dominated by a sod of rhizomatous graminoids, and these are usually dominated by species of sedge with some forbs intermixed. Some common moist turf species in Idaho include cloud sedge, payson sedge, various species of pussy toes, and mountain avens. The dry version of alpine turf, as you might imagine, the main difference is it does not have a season-long, consistent supply of water. It's also dominated by graminoids, but these can be bunch grasses, have a bunch habit versus just being rhizomatous. Again, with some intermixed forbs usually present. It's common species in this kind of plant community: blackroot sedge, dunhead sedge, species of draba. In this case, I put a picture of Nuttall's draba, and the alpine version of common yarrow. Scree fields, they're dominated by loose scree, talus, usually patches of boulders mixed in, some exposed bedrock, with sparse vegetation that usually consists of scattered individuals or small groups of plants. So these images kind of hopefully show that those patterns. Some common scree species in Idaho mountains: cutleaf daisy, alpine colomia, mountain penstemon, sky pilot. Again, most of them are really quite showy. Some other ones are nutholes, sandwort, moss champion, silky phacelia, and alpine dusky native. So you know you're in a nice spot when you start seeing all these guys. In Tom Lopez's guidebook to the mountains of Idaho, he lists more than 50 mountain ranges and subranges in Idaho. However, only about 15 or so reach elevations of 10,000 feet or higher, so high enough to support alpine vegetation. And most of those are in the east central part of the state. So most of our high alpine is in this part of the state. So this map is produced by Jessica Irwin. It's just a graphic showing where the main mountain ranges in Idaho are located. There's been a lot of folks who have collected plants at alpine in Idaho over the years, and they've all contributed to our understanding of the alpine flora. I just want to mention 7 people who stand out a little bit in my mind. The earliest alpine collections I could find for Idaho were made by Per Axel Rydberg back in the 1890s from the Henry Lake Mountains, west of Yellowstone. Rydberg was a Swedish-born American botanist who collected extensively in the American Midwest, Great Plains, and also parts of the Rocky Mountains. He described over 1,500 plant species during his accomplished career. Pretty impressive. John Christ was a prolific plant collector in Idaho from about 1930 into the 1950s, while he was working for the Soil Conservation Service, which I think now is the National Conservation Service, Natural Resource Conservation Service. He collected in the mountains throughout the state. In fact, I don't think anybody has ever collected more plants in Idaho than John Christ. Charles Leo Hitchcock made numerous collecting trips to Idaho while he was a botany professor at the University of Washington from the 1930s into the 1960s. He's best known as being the primary co-author of Flora Pacific Northwest. And Ray Davis, he taught botany at Idaho State University for many years, where the herbarium is named in his honor. He also collected extensively in the Idaho mountains, and he was a contemporary of Hitchcock's. Doug Henderson was a student of Hitchcock and went on to become a professor at the University of Idaho and was the director of the Stillinger Herbarium at the university from the early 70s to 1996. He collected throughout the whole state of Idaho, but was particularly prolific in the east central mountains of Idaho. And the next two people I want to talk about are two of Doug's students. The first is Steve Brunsfeld. He collected extensively in the alpine in support of his master's thesis, which was alpine flora of East Central Idaho. He was often accompanied by his wife, Pam, who many of you know, on these forays into the mountains. And Bob Mosley, he was another student of Doug's, whose master's thesis took him into the high country of East Central Idaho. And as a student, and then later with the Nature Conservancy and with the Idaho Conservation Data Center, no one's collected more plants in Idaho as alpine than Bob over time. Then I'm going to zoom in a little bit on Idaho Peaks Project itself. 2021, small core group of botanists got together to try to get this project off the ground. And one of the tasks was to make an initial list of peaks that might be suitable for the project. Some of the criteria we used to develop an initial list was geographic distribution. We want, to sample as many different mountain ranges in the state as possible. Geologic substrate variability, so try to sample as peaks with as much different geology as possible. We wanted peaks with relatively straightforward access, no technical mountain climbing. And we also gave priority to peaks that had little, if any, previous plant collecting history. Before we got started, we had, several other tasks that had to take care of. Well, one was we had to recruit team leaders and assistants. We produced preliminary plant lists for each peak using information from the Consortium Pacific Northwest Arboreal website. And then we had to get plant collecting permits from the Forest Service. Just want to review what we did and how we did it, basically. So the goal was to sample as much of the peak's alpine zone as possible. Upon arriving at a peak, the team leader would delineate the survey zone that he or she wanted surveyed based on features of the topography, the vegetation, substrate stability, and just general safety concerns. The survey itself was conducted by usually a series of these loose, meandering, intuitive transects that allowed you to sample all aspects and as many micro habitats on the peak as possible. That was kind of the goal. We wanted to do as thorough as possible inventory of all the vascular plant species in the survey zone, using collecting both voucher specimens and also on field observations. Using field observations allowed us to not spend too much time collecting common widespread species that team leaders could identify in the field pretty easily, which then allowed more time to survey for rarer species and search a larger area of the alpine more thoroughly. We also recorded abundance, phenology, habitat, and some other information about each species on the summit. Now, we also collected leaf tissue samples for a subset of the vouchered specimens. And these are all sent to Dr. Hannah Marks at the University of New Mexico for her ongoing DNA analysis research on high elevation plant taxa. We also collected rock samples from each summit to verify the geology, took plenty of photographs of the summit and surrounding landscape and as many plant species as possible. And then finally, we documented the survey zone on a map so we could estimate area. This is just, and all this information is recorded on a field form, an example here. So what have we accomplished so far? Well, this table shows us that we've done 21 peaks so far, 10 in 2022 and 11 in 2023. We've done peaks in 12 different mountain ranges, 7 different Idaho counties. You can see that most peaks exceed 10,000 feet elevation. The main exceptions are in North Idaho, where there are no peaks that reach that high. We've also done a pretty good job of getting a mix of geology. We have collected on summits that are intrusive igneous rocks, such as granite, extrusive igneous rocks such as Challis volcanics, metamorphic rocks such as limestone and quartzite, and then some sedimentary rocks such as siltstone and sandstone. So I think with 21 done in 2 years, we're pretty well on our way to reach our goal of 25 in 3 years, and hopefully maybe build from that in the future. This is just a map showing the distribution of the peaks that we've surveyed so far. A few in North Idaho, a few along the eastern edge of the state, but the bulk of them in the east central part of the state, which makes sense because that's where most of the state's alpine is located. And I'm just going to show some pictures of some of the summits that have been surveyed so far. Hemingway Peak in the Boulder Mountains. Rock Roll Peak also in the Boulder Mountains, and there's Beth Corbin trudging up the Summit Ridge. The Backdrop Peak in the Smoky Mountains, so that's north of Ketchum area. Phi Kappa Peak in the Pioneer Mountains. Peak 10644 in the White Knobs, which are located a little west of Mackay. Some peaks don't have names, and we just went with what the elevation was for its name. South Wet Peak in the Lost River Range. Another peak in the Lost River Range, we gave it the name Three Color Peak in the shadow of Mount Bora. Both North and South Twin Peaks in the Salmon River Mountains, west of Challis. 2 peaks in the Centennial Mountains, Mount Jefferson and Peak 9790 along the Continental Divide. So half that mountain's in Montana, half's in Idaho. Mount Baird in the Snake River Range. This is the only summit we've done that's south of the Snake River. And then Stevens Peak in the Bitterroot Mountains, and Ward Peak also in the Bitterroot Mountains along the Continental Divide, and with Derek Antonelli there taking his notes. So that just gives a kind of a cross section of what some of these peaks look like. And this slide is just to show an example of how we delineate the survey areas to estimate area. And if you note that the downslope end of the survey area usually coincides, at least in places, with the upslope extent of trees. So what have we found so far? Well, so far we've recorded about 318 species, mostly forbs, but quite a few graminoids, and as you might expect, fewer woody plants. The number of plants per peak really has varied quite a ways, from 13 to 73. 5 peaks have more than 50 species. 2 peaks have less than 30, and all the rest are somewhere in between. We've collected 630 voucher specimens and 414 leaf tissue samples. The size of the survey areas is also ranged widely from less than a half acre up to 36 acres, with most summits being less than 15 acres. Those 318 species represent 42 plant families. By far the most common one is the aster or composite family with 69 species. The grass family, the mustard family, the rose family, and the carnation family all also contribute 5% or more to the diversity. The most common genera we've recorded so far. Leading the way is Erigeron, daisy, with 17 species. That's kind of sort of surprised me. 15 species of sedge, carex, 10 species of paintbrush, the castanea, 9 species of poa, the bluegrasses, and 8 species of penstemon. Another surprise for me was that 43% of the species we recorded are found on only one peak. And most of the rest are on 2 to 5 peaks. Only 12% of all the species that we've recorded occur on more than 5 peaks. Erigeron compositive, cutleaf daisy, occurs on 16 peaks, which is more than any other species. And then we had 4 species that occur on 14 peaks. Rosy pussy toes, white bark pine, sky pilot, and the grass spike tricetum. We've also documented 11 populations of species on the Idaho rare plant list so far. Most summits had at least one. You can see that most have a conservation rank of G3 or G4 or G5. They're more common elsewhere than Idaho, and that rank implies that they're either globally secure or at least not threatened with imminent extinction. And I thought I'd just show you a few of them. The first one is Nevada Holmgrenii, a false candy tuft that was recorded on Rock Roll Peak by Don Mansfield and his crew. Until recently, this species is only known from the central mountains of Nevada. So finding it here in central Idaho is quite remarkable. And I'm not sure if more scrutiny or study is needed to determine if it's really the same species or not. But it's a white flowered mustard. Well, this picture has it in fruit. Another white flowered member of the mustard family is limestone Draba aureobata. It's actually an Idaho endemic, found only in the central and east central Idaho mountains, where it's restricted to limestone knockout crops. It's one of 5 Draba species that are endemic to the central Idaho mountains. This one was picked up on South Wet Peak in 2022. Shasta sedge, Carex germiniformis, is kind of a tough bunch forming sedge that grows in rocky habitats at high elevations. It's most common in the Sierra Nevada of California, up in the Cascades of Oregon and Washington. But then there's a series of disjunct populations in the central Idaho mountains, and it's been picked up on 4 of the summits we've surveyed so far. Ivesia tweedii, Tweedy's Ivesia, is in the rose family. Its main distribution is in the mountains of Washington state, but there are a few disjunct populations in northern Idaho and adjacent Montana. And Derek Antino and his crew picked it up on 2 of their peaks in the Bitterroot Mountains. There's 2 other species I want to mention that are quite noteworthy, I think. One is alpine paintbrush. This is a real pretty yellow paintbrush that has a very strange distribution. It's known from the Colorado Rockies and then one population around Mount Jefferson in the Centennial Mountains. It was documented there a number of years ago. And then this year, when the teams were up at Mount Jefferson and the nearby Peak 9720, they picked it up again. It's not on the Idaho rare plant list, but it might be one might be worthy of consideration. The other plant I want to talk about real quickly is Potentilla transitoria, Great Divide Cinquefoil. This is the newest addition, excuse me, the newest addition to the Idaho flora. Take a quick drink of water here. Yeah, this is the newest addition to the Idaho flora, described by Barbara Erda, sitting here in the back, only in December of 2023. So doesn't get much fresher than that. It's been picked up at Hemingway Peak in the boulders. It's so I guess according to Barbara's paper, it's known from central Idaho and then extends eastward into parts of Montana, Colorado, and Wyoming. The name transitoria refers to the leaf morphology, which is transitional between two sections within the large Potentilla genus. And the common name Great Divide Cinquefoil was proposed because the type location and many of the other substantial populations for the species occur near or on the Continental Divide. So very, very cool. I'm sure Barbara could answer more questions about this afterwards. Well, I'm going to spend the rest of the talk here just talking about some of my favorite plants that we've come across so far during this project. Saxiferca is a very large genus, several hundred species, well represented in the northern latitudes around the world. We've picked up 4 species in the Idaho Peaks Project, one of them being purple saxifrage. It has a circumboreal distribution, which means that it occurs at high latitudes around the world, not only North America, Asia, Europe, Greenland. In North America, it extends as far south as central Idaho and western northern Wyoming. This plant is a record holder. It's one of two vascular plant species that occur on Coffee Club Island, which is an island north of Greenland, and making it the most northerly occurring plant species in the world. It also occurs at 14,700 feet in the Swiss Alps, making it the highest elevation plant species in Europe. In addition to all that other cool stuff, those beautiful little purple flowers are sweet and edible. Spotted saxifrage is another circumboreal species, at home in talus slopes and rock crevices. Individual flowers are pretty small, but when you look at them closely, I think they're quite stunning with all those speckled with those pink dots. We've documented 4 species in the primrose family so far, one of them being a shooting star, a plant many of you are familiar with. But the other 3 maybe you're less familiar with unless you spend time in the mountains. One of these is northern rock jasmine. It's an annual, the only annual we've picked up so far. It's also a circumboreal distribution. It has a dense rosette of basal leaves, and then this candelabra sort of arrangement of small white flowers. Rocky Mountain Douglasia is a cushion plant with really pretty small pink flowers that bloom soon after snowmelt. The genus Douglasia is named in honor of David Douglas, a famous botanical explorer, one of the first in the Pacific Northwest in the early 1800s, when he discovered many new species to Western science. And then there's Parry's primrose. To me, this is one of those species that you see for the first time and you never forget. With this really vivid magenta flowers and this rosette of thick spear-like leaves. I always know I'm having a good day when I come across this plant, daggerpod, another member of the mustard family. It has small white flowers that bloom really early after snow melt, so you're much more apt to see it in fruit, as in this photo, with these kind of dark dagger-like pods. The genus name A. Nelsonia is in honor of Avon Nelson, who was a preeminent Rocky Mountain botanist during the first few decades of the 1900s, who taught botany at the University of Wyoming for many years and founded the Rocky Mountain Herbarium. You can see they dressed a little differently when they did botany back then. I'm gonna get my bow tie next time. What do you think, Don? Go out in bow ties? There's no shortage of little yellow flowered composites in Idaho flora, and that extends into the alpine, where we've recorded at least 25 species of small yellow flowered composites. Three of my favorites, though, are mountain butterweed, rock butterweed, and alpine gold. They're all widespread in the Rocky Mountain region, and all quite at home in talus slopes and rock cracks. Mountain butterweed is essentially a hairless plant, whereas rock butterweed has kind of a thin covering of hairs on its stem. Alpine gold is probably one of the most glandular plants in Idaho flora. It's just covered with soft glandular hairs that make it very sticky to the touch. We have 7 species of Townsendii in Idaho. 4 make it up into the alpine. We've documented 2 so far: mountain Townsendii and Parry's Townsendii. Mountain Townsendii is basically a stemless plant. The flowers just sit right on top of the leaves, whereas Parry's Townsendii obviously has a stem and then a giant inflorescence on top of that. The genus Townsendii is endemic to Western North America, and is named the name Townsendii honors David Townsend, who was an early American botanist from Pennsylvania. One of my favorite groups of plants. Well, the Idaho Peaks Project could not have happened without the help of numerous volunteers. We're very lucky in Idaho to have a number of botanists who are familiar with the mountains of the state and also its flora. And more than 10 of them volunteered to be team leaders or co-leaders, and they're listed here. And then we're also very fortunate to have over 30 people volunteer to assist on one or more peaks, and they're listed here. And hope I didn't forget anybody. Very few of these photos are mine, most are other people's. And here's a list of photographers for this presentation. I thank them all. I also want to give a shout out to Dr. David Giblin, University of Washington, for his help getting the Idaho Peaks Project started. And also to Dr. Matthew Cohn and Geoscience Department at Boise State University for his help identifying all our rock samples. And finally, to the Native Plant Society for providing funds to reimburse participants the gas money driving to and from the mountains. And I'm going to end with this collage of team members being in a place they love, the mountains, doing a thing they love, looking at plants, and playing with plants and learning about plants. So with that, thank you very much.